Volcán de Fuego in Guatemala is one of the most active volcanoes in the world. The frequent eruptions deposit ash, lava, and other volcanic products on the volcano slopes. Over time, this material builds up and can become unstable, eventually collapsing into fast-moving hot avalanches called pyroclastic flows that pose a hazard to communities around the volcano. Monitoring and studying Fuego's activity is no easy task, but the volcanologists of Symeon, Guatemala's National Institute for Seismology, Volcanology, Meteorology and Hydrology, employ different tools and techniques to achieve this. On this day, our team had a specific task, which meant we had to safely access the eastern flank of the volcano and get as high and close to the crater as we safely could. Join us for a day in the life of a volcanologist. First came the drive. A 4x4 carried the team up the volcano as far as the rough terrain would allow. When the vehicle could go no further, the only option was to continue on foot, cutting a path through vegetation with a machete. Once the team reached a clear opening, the next stage of the mission moved into the air, and drone took over, flying across the slopes while we monitored it from a safe distance. The drone captured striking footage of the volcano, but its main purpose was scientific. It surveyed the slopes in detail, collecting the data needed to create a 3D model, which allows us to calculate how much material has built up on the volcano. By measuring the buildup, we can begin to understand the processes and eventually when, where, and how the slopes become unstable. The estimation of the volumes of the material on the volcano will inform numerical simulations, enabling the hazard of pyroclastic flows to be anticipated more effectively. The project, funded through an urgency grant, is a collaboration between BGS, Guatemalan scientists at Symeon, and international collaborators. This work builds on the knowledge, experience, and constant monitoring carried out by the scientists of Symeon. Back in the UK and with our partners abroad, we are analyzing more samples and drone data, which will allow us to understand these processes. This collaboration combines monitoring with new data and modeling approaches, developing new ways to understand how volcanoes evolve through time and how the hazard of pyroclastic flows can be better anticipated.